All right, this is check for understanding number 3 in the note package that we gave you last class. This is the third example of the application for the point slope formula. So could everybody please get that out? The point slope formula, check for understanding number 3. We didn't quite finish that last day. Get it out. Krulicki, you got it out? Stephanie, make sure that Lindsay does not have her music on. Okay. All right, welcome back. Let's read the question again. Temperature in degrees Celsius is a linear function of the temperature in degrees Fahrenheit. The boiling point of water is 100 degrees Celsius and at the same time 212 degrees Fahrenheit. The freezing point of water is 0 degrees Celsius, which is 32 degrees Fahrenheit. So it says Celsius is a linear function of Fahrenheit. So Fahrenheit is the independent variable, and Celsius depends on the Fahrenheit in this situation. So I've jumped ahead a little bit. I've plotted some points. I've truncated the x-axis starting with 30 degrees Fahrenheit, and I've gone up by 60 for every 2 boxes. For Celsius, I've gone up every 2 boxes to equal 2. Every 2 boxes is 25 degrees Celsius. So I've wound up with a fairly well-spaced graph, and now I've labeled the 2 points that were given. We were given that at 32 degrees Fahrenheit, we have 0 degrees Celsius. So that's this point right here. Fits nicely right on the x-axis. It's an x-intercept, in fact. Also over here, we're given that at 212 degrees Fahrenheit, the temperature of boiling point of water is 100 degrees Celsius. So we have 2 points. In order to draw a line, you always require 2 points. So at this point now, I will draw my linear function, making sure that I have arrows on either side. And as was stated last class, we now have enough information to come up with the equation of the line. The new method, the new strategy, is the strategy called point slope formula. Okay, so what we require is a point and a slope. Notice we have 2 points for which to find the equation, but we don't have a slope. So the first thing you want to do is find the slope. So let's go do that. So you remember your slope formula, m equals fraction y1 take away y2 divided by x1 take away x2. So that leaves us with, pick a y coordinate, I'll pick 100. 100 take away 0 divided by 212 take away 32. So once again, 100 take away 0 divided by x1 take away x2, 212 take away 32 leaves us with 100 over 180, which simplifies to a slope of 5/9. So I'll just highlight that. There's our slope. In order to make the point slope formula applicable, you need a point and a slope. So we need to pick a point. It doesn't matter which one we pick. I'll pick this one, 212, 100. So we pull out the formula we derived last day, y take away y1. So that's y as a variable, take away one of the y values, equals the slope multiplied by x, the variable, subtract the other x value. The x value and the y value must come from the 1 point. So in this question, we have y take away 100 is equal to slope multiplied by x take away 212. So now we can state the slope, y take away 100 equals 5/9 is what we came up with for slope, 5/9 x take away 212. So there you have it. There's the equation of that line in point-slope formula. And also in this situation, we have replaced the letter Y with Celsius. So what we could do is we could fine-tune this equation, and instead of writing Y, we could replace it with C for Celsius. Celsius minus 100 equals 5/9. Slope, whoops, 5/9. And X is being taken place by Fahrenheit, so we'll call that F minus 212. So let's get that on the page so you can see that. Okay. The second part of the question, part B, says use the equation to determine the temperature in degrees Celsius at which iron melts at 2,795 degrees Fahrenheit. So that means that we need to convert from Fahrenheit to Celsius. So one thing we could do is use the equation that we've generated in part A. Replace Fahrenheit with the temperature 2,795 degrees. So as you notice, we've done that right here. Replaced F with that number. And now we need to solve for C, Celsius. So let's get out our calculators and isolate that letter C. So here goes. Be patient with me for a second. Here we go. Okay. So I'm going to calculate the right-hand side first, which is 5/9. 5/9, and we need to multiply that by the difference of 2,795. Take away 212, and what we get is 1435, and then we'll need to move the negative 100 to the right side, so we'll need to add 100 to both sides. So what we get is 1535. So 1535 is our Celsius conversion. We'll put that right in here. So what we would say now is that the temperature in degrees Celsius where iron melts would be 1,535 degrees Celsius. Okay, thanks for listening. We will now proceed to check for understanding number 4.